we are divided into male and female. That's a normal distinctive structure which we have. Okay, there is not much of a difference into this, into our human society and all. So we are also divided into two parts. Okay, so distinction is very important because it makes the calculation a little bit easier. So now why we need a theorem? So binomial theorem, everyone always think that a plus b whole to the power n finding is binomial theorem, but it's not like that. But it is like, this is a story of an integer. It's a story of an integer. So why or how on earth is the story of an integer? So an integer starts its life, for example, this is our integer. Okay, so its last is life very happily. So even let's the integer's name is Rama. Okay, or you can name it Ramanujan as well. So Ramanujan, so is named after a famous mathematician Ramanujan. Okay, so this small integer starts his life, okay, in a very happy mode. And the kind of formulas he is discovering, since this is applicable for smaller values for sure. Okay, like the original Ramanujan who discovered a lot of formulas, for example, finding the next prime. So his formula was applicable for 1 digit, 2 digit, 3 digit, 4 digit, 5 digit, 6 digit. But when you are going to 7, 8, 9, 10, 11th digit problems, okay, for example, 6, 7, 8, 9, 4, 5, 6, 3, 2, 1, 1, 4, 7, 3, 4, and 1. And what will be the next prime to it? Then the formula started failing. So now there is a problem. So that now when this integer is getting a bit bigger and bigger and bigger, okay, now things started faltering. So now the integer is finding not a very proper clue of how to do things. So then it got a help from a binomial structure. So now binomial told that in some integral points, if we just divide the thing into two subsections, okay, so let's go for, and the subsection need not to be always equal, then your problem can be solved. So we'll come to it at the end of the class. Okay, so an algebraic expression of two dissimilar terms. So the basic expression is any algebraic structure of two dissimilar terms. This is very important. It's not given in books, so it's not a bookish thing I'm saying. So any algebraic expression of two dissimilar terms, this similarity is very, very important. Two dissimilar, sorry, I'm waiting point. So dissimilar terms with positivity and negativity sign between them is called a binomial expression. It's a binomial expression. Okay, so it's a normal thing. So I have an algebraic expression. So even, is it a binomial expression? Answer is yes, it's a binomial expression. So every time not to the power n makes it a binomial. So even nothing in the power makes it a binomial. So 5 minus 6, it's a binomial. Yeah, so these are 2. And remember that two dissimilar terms. So it need not to be a minus b always. So it can be a normal term. Okay. So is it a binomial?
Yes, sir.
Let me finish. Okay, is it a binomial? Z to the power psi square, x square whole root. Answer is yes. It's going to be considered as a binomial. No matter what, how complex way we can do it, it's a binomial. So is it a binomial a plus b plus c whole to the power this? Answer is yes. If we just consider b plus c together another term, and then we can consider this bi thing. So obviously it is possible that more than two things can be subdivided into two things. So if things are more than two, so we can always split it into two. So remember that in ISI study or in CMIs or any kind of RM or any kind of higher level in Putnam entrance examination, any kind of higher level, so they want you to understand the basics of it. Okay, so formula and all these things, whether you know it or not, doesn't matter. So I haven't seen a single case that, for example, in class 11-12 examination, sometimes they, in ISI examination also, they will write the formula in the beginning. These are the formula you will need, because they know that for formulas the problems are, this is not the problem problem of the problem, that whether you know the formula, whether you can figure out the formula, whether you can apply the formula or not. Okay. So whether your intellect can get you to that level where you at least know that what to do after applying the formula, because till the formula part they have given already. Okay, so let's see this. So now here so every expression and basic binomial coefficient and all. So what is this coefficient thing? Now coefficient plays a very important role. So if I have this expression here, so x plus a whole to the power n. So what is this expression? nc0, okay, into x to the power n minus 0, a to the power 0. Then nc1, x to the power n minus 1, a1, nc2, x to the power n minus 2, a square. In that way we are going, and the last value is ncn, x to the power 0 and a to the power n. There is no problem in it. So we can write it in the summational format. This is ncr, x to the power n minus r, a to the power r equal to 0 to n. So this is the complete expansion we have with respect to. Now the binomial coefficients are these: nc0, nc1, nc2. So these are the binomial coefficients. So now, why these coefficients are very important for our calculation? For example, in differential calculus, in differential equation based formats, when we will do, you will see that the total number of times you differentiate, total differentiation is depending on the number of parameters in a system. So number of parameters are the decider in a particular system. Those who are joining at 7:20, they are requested that from the next class, please join 5 minutes before. The link will be sent around 6:40, 6:45. Whether I join or not, you just send your request, okay, so that whenever I will join, we can start our classes. So don't use the old link. Every class you will get a new link. Okay, so no point if you join via old link, it will be useless, and while the class is going on, if you're texting me, I will not be giving any answer. Okay, so this is not my job to add everyone. There were classes today at 7 p.m. right? Yes, my dear, classes are there and it's happening. Try by laptop. It's best to work on a laptop. Also, you can do it by phone. Okay. Okay. In order to, the difference between distribution and theorem I will tell you later. Okay, so let me just tell you about this parametric structure. Okay, now one thing, let's start with one thing, that why binomial plays a very crucial role. Sometimes the expression is not enough. So if I tell you that 101 to the power 50, this is an 100 to the power 50 plus 99 to the power 50. Is it greater or less? Obviously, there is another part they are equal. Okay, so is it greater or less? In order to do that, so we need to take a help from, little bit of help from the binomial. Okay, so 101 to the power 50 minus 99 to the power 50. If I do that, so this is 101 is 100 plus 1 to the power 50 minus 100 minus 1 to the power 50. Now you can understand why I've taken 101 and 99. So n plus 1, n minus 1, the similarity format will be there. So a plus b whole to the power n minus a minus b whole to the power n. So if you take into consideration of all the thing, so let's see what happens over there. So x plus a whole to the power n minus x minus a whole to the power n. So this is x to the power n plus, so all these x terms are gone. Okay, there is no problem with that. So we are left out with 2 nc1 x to the power n minus 1 into a1 nc3. All the odd terms will not be perished, it will survive, rather say, and go on. Okay, so it is all the odd terms. So here also 2 into 50c1 100 to the power 49 plus 50c 100 to the power 49 and 50c3 100 to the power 47, 50c5 100 to the power 45 dot dot dot. Okay, so you don't need to write till 1 3 till so it goes till what, 50c 49, so you don't need to write that. So the very next case, what will happen to, so remember that in this kind of question your job is to do as less as possible and gain as much as possible. So 100 to the power 49 will be common. Okay, we can, if we can take, just remove the first part, and then from the next we can take 2 common. So 50c3 100 to the power 47, 50C5, 100 to the power 45, dot dot dot. Okay, so here it is 100 to the power 50 plus something positive number. So this is all of this complete thing is a positive number, a positive number. So this thing is has to be greater than 100 to the power 50, isn't it? That's for sure. So obviously now this expression has given birth to this. So 101 to the power 50 minus 99 to the power 50. This is greater than 100 to the power 50. So just by a little bit of changes in the left and right direction, we can say that this is correct. So this is true. So anyway, if it is option A, option B, option C, so option B is correct. So now you can see just by using a small pattern based analysis how we can arrange the structure. Okay, next.
Sir, could you please explain again? I couldn't understand.
Yeah, sure. For example, the question takes a turn around from this zone. So this is the formula which we have. Okay. Now the formula tells us that, so this is 100 to the power 50. Okay. And 2 into 50C minus 1. So that is from this part. So this is very mechanical. And after that, intentionally, we have taken this. So 2 into 50C 100 to the, so 2 into 50C1 is what? I think you're having problem in this. So 2 into 50C1. So 50C1 is 50, 2 into 50 is 100. So 100 to the power 49 into 100 is 100 to the power 50. So that part is gone. So this is the family. This family is okay. And the rest of the stuff is here. So 2 into some positive numbers. Okay. So now this thing, so 100 to the power 50, and then we have some positive number over here. So that has to be greater than 100 to the power 50, and then a small bit of adjustment. I think you are having problem in this way, is it?
Yes, sir. Thank you, sir. I understood.
Yeah. So those who have done the previous session, so are you enjoying this session a little bit better, or the previous session was better? So you can just unmute and tell me. I just want to know it as well.
This is a bit better, sir.
Okay. So better in what aspect?
Sound is clear.
Yeah, in this one?
Yes, sir. Their sound is more clear.
Yeah. Or anything else you want to just mention with respect to, I think the legibility of the board is also better.
Yes, sir. The area has increased on the board.
Yes, sir.
Yes, sir.
Brightness problem has
And
been.
it's also visibility is also clear here.
So it took me a long time to just decide on this. Okay, I'm also very, what you can say, the best word is excited to work on this. But you know, it's very hard to write with this Wacom. Okay, but I think I'm managing well. So is it understandable to you all? So the handwriting?
Yes, sir.
Yes, sir.
Ah, fortunate. Okay. So in ISI, you know how we write. So they have given us a big smart board, huge board, and there we write with a pen. With a pen of the size of the pen is almost like a big sketch pen, this much fat pen. It's just like a light pen. What you write on that, and that is reflected on the board. So you will lose the entire energy to do the class once you just hold the pen. Anyway, in that way, the costing of the board is 7 lakh rupees, one of the costliest boards in Kolkata available. But anyway, at the end of the day, it's completely useless. once I start the live classes, I have bought 2 projectors. So once I will be doing it in the same way, and you will be seeing the screen over here. You have a big screen, so you'll be seeing directly here. So there are a lot of new thoughts I have given it, that the Omicron days are over, let you guys be vaccinated. I think none of you have got vaccines. So if 1 or 2 who are of 18, so they given it a try. But I still would say, you see, 17 years or 16 years of age, and suddenly if you are 17 years 11 months, if it's 29 days, you can't take the vaccine, and you are 18 years and suddenly you can take the vaccine. So I think you should wait for 19 and a half. So in that way, I'm not a vaccine expert, but that is what been said by those students, those of my friends as well. Okay, even the vaccine government would say, so you should wait a little bit, okay, with respect to this kind of stuff. So don't get it very quickly, get jabbed by that. Okay, now, so let's get back to our study. So now what happens, and here the best thing is I can change the color within a flick of a pen. That's the best thing. Okay, so what if, so we know this, every time it's like a Pascal's triangle. What is a Pascal's triangle? So 1, 1, 1, okay, then 1, 2, 1, then 1, 3, 3, 1, okay, then anyone know? 1, 4, 6, 4, 1. It's a power game I'm talking about. So it is x plus a whole to the power 0, x plus a whole to the power 1, x plus a whole to the power 2. So means x square plus 2ab plus b square in that way. First term, second term, third term. X plus a, this. So this is the coefficient game. These are all the, this is a coefficient forms this Pascal's triangle. What will be the next one? Any idea? 1, 5, 10, 10, 5, 1, right? So remember that everything has a common pattern. These two are fixed. So these will be fixed. This area will be fixed. This area will be fixed. This time everything will be double, 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 double. Game will be played. And here muting is very easy as well. Okay. Ayush, you are joining the class at 7:36. Okay. So this time this allows me to take attendance of you guys as well. Who is attending at what exact time? This is a paid version. Don't take it as a free version like you do it in school and colleges or in other centers. So here I can track everything. Don't worry, I will not be tracking, but here I can keep a track. So next time when you start at 7:36, try to see that you have lost. You don't know when I started. Because if the previous class have, for example, today you are very unfortunate that I started at sharp at 7:02. Okay, although the class started at 7:09, but I was here at 7:02. So I can see you that you are 34 minutes late in my class. But sometimes I start at 7:15, 7:20 because of the last session ends up late. So then you are lucky. So don't try to play this game of luck. Okay. So now let's get back to this. Do you have to remember this? Answer is not at all. You don't have to remember this. Okay. Is there a particular relationship? You can see that this is 4, 1, this is 2, this is 3. Okay. I think I'm using a very, let me use, yeah. This is 2, this is 3, this is 4, this is 5. So obviously in that way, so 1, 6, 1, 6 pattern will be there. Okay. But it is not doubling every time. So this coefficient is also forming a NC1, NC2, NC3 kind of a format. So anyway, we can do this kind of stuff later on. And don't mix it up with your class 11, 12 type of questions. Okay. So here, the coefficients are important. Why coefficients are important? Why coefficients are important? What we want to know from this coefficient, what they are telling you. So the coefficient is telling you how powerful you are. If I tell you 24x, if I tell you 2240x, if I tell you 1240x, and if I tell you 4000x. x. So which makes it stronger? Obviously this is. So is the variable changing? Answer is no. Every time the variable is there. Is the power changing? No. So only the coefficient is changing. So changing the coefficient makes a drastic change in the entire pattern. Okay, that's the spirit of the entire game, which we are going to play in the upcoming time as well. So why the coefficient is crucial? Coefficient is crucial for determining. So we'll be coming to that. So power is important, variable is too important. So let me tell you about a thing which you not again find in any book, which is called what is called a variability fixation structure, variable fixation pattern, VFP. You don't try to Google it, you won't find any result. Okay, it's my specially given name. So for example, I tell you that y is associated with x. Y is a function of x. You're very happy. And I say that y is x squared. Then I say y equal to 3x squared. So, okay, you are putting some more information. Then I say y equal to 3x squared plus 5. That's it. I can't add more information. Then I can only add one thing, that is this. Or I can add a power. Or I can add a log. See? So I can keep on adding these things. Okay. I can add an algorithm. I can put an inverse. If I put a cos, then an inverse function. So anything I can put. So like after a certain step, I will have to stop. Even I have to stop. But what happens if you say, sir, that, sir, what happens if I just put another z to it? So then suddenly, which was y is a function of x, now will become y is a function of x comma z. Now, which is much more explanatory with respect to mathematical formation. Obviously, the second one. Now, here comes the important concept. If I include another variable to it, for example, log of this thing is there, z is there, and w to the power 104 with any power. So now this becomes a little bit more apt because now x, y, x, w, and z is trying to explain y. So if I keep on adding up variables, then the system will become much more sorted, isn't it? And this is the wrong concept of algebraic assimilation. That says that sometimes we intentionally add some extra variables to a system to make the system better than others. Where those systems which doesn't have that much variable, for example, this has x, y, z, p, q, and they are trying to explain why he is happy. And here only we have p, we have a, b, and c. They are trying to explain why she is unhappy or he is unhappy. And we are saying that the better explanation comes with x, y, z, p, q, r, s, t, because they are very large in numbers and they are much more authentic to explain. And the unhappiness is explained by this is not. So let me give you a real life example. In real life, binomial theory explains, it's a very interesting thing. So binomial tries to explain the logic behind the entire expenditure of a person. Okay. So what is the consumption pattern of a person? So your consumption, if I just put it as C, is a function of what? First is your income. Very good. Your income is low, you're consuming less. Your geographical position, where do you stay? For example, in my area, there is an app called Licious. In Kolkata also, there are two parts, North Kolkata and southern part of Kolkata. Even North have two parts, the extreme North and the old North. Okay, so most of you don't know it, whoever stay in Kolkata also. This old North is actually the area where the metro actually runs. That's only the old North Kolkata. Anything beyond that zone is the extreme North. Okay, so I'm not extending because some of them who doesn't stay in Kolkata, they will find it very boring. Okay, so now Licious app, which actually sends around chicken mutton thing at your home. So they are available in southern part of Kolkata, northern part, but only in extreme north, but not in old north. Okay, so geographical positioning wise, I, who am a citizen of this old Kolkata, and my centers are in this and this and in these zones. So when I am at my home, I can't order this. So on those days, my consumption for Licious is 0. And if I add these two positions, my consumption is okay because they are delivering at that. So geographical position matters a lot. Okay, even if you are staying at a particular city. Clear example? Second is your taste. Second, lastly, is your preference. Now, okay. Now, is taste and preference same? So remember that many of the variables which we'll be using in binomial, so they will be very close in their characteristic, but they are not the same. So these are like this you will study in economics, but I will be assimilating in maths because if you heard about John Nash, so John Nash was not actually an economist, he was a mathematician. So he worked on game theory, and which later worked wonders for the entire world of maths and game and economics, econometrics, everything. Okay, so these are all interrelated. So taste is kind of a thing which is constant, and preference is a kind of ordering which you provide. Now, also, if till this it is okay, and there is also your old savings. How much money you have it in your bank always decides that how much to consume more. If you have a lot of money in your bank saved, so then you can say, okay, let's give it a try. But after this, if I tell you that the color of the food, that is also, but this is weaker than the others. The person who sells the food is the sales boy or the sales girl. The poster, the advertisement, availability of parallel products. So many variables if I still keep on adding to it. So, and you must be believing, okay, so sir has added a lot of variables, so I must be having a lot of great information. But the actual thing is that the entire data is now becoming a function of a lot of different things. Now, who wants to join now? Tuhin Shubhra Ghosh. So now a lot of new data is being added to the system. So the system is congested. So first variable, second variable, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 11 variables are there. So if I give you an equation with 11 variables, if I give you 11 different equations, so is it easy to solve? Answer is no. So binomial says it is always to split it into two parts and let's see which part is important. Then I can split it into two parts. Let's see which part is important and then you find the best one. Didn't get it. So let me give you another example. This is the first class, so that's why a lot of good examples are coming in. Don't expect that in the next classes also you will get to do this kind of saucy examples. Okay, then I will be asking a lot of hard questions every second. Let's see that you're on a train. Okay. And suddenly you spot a girl on a station. And if you are a girl, then you have spotted a boy on a station. Okay, and the boy or the girl is wearing a medical robe on him. Okay, so you understood that it's a medical student, and I'm talking about maybe 2025. But you have also in the graduation days. Okay, so you are in ISI, in CMI, so you are also strong student. Okay, so now suddenly just you fall in love with a boy or girl and you want to find her or him. Now the question is, in your city, if you are in a particular city where there are maybe like 1 crore people, you say it to your friend and your friend said, how to find someone from the 1 crore people? It's impossible to find. Forget that, girl or boy. You become very unhappy. And then suddenly you remember, once sir told me about that binomial thing and all. Okay, it was anyway a normal class, but suddenly the formula of binomial will come to your mind and you started believing that yes, it is possible to find that person. How? That first of all, okay, as every time boy, girl, I'm just taking one. So let's presume that we are finding a girl. Okay, very sorry, girls, I'm just taking, partaking to be a boy who is finding a girl. Okay. Next class, promise, I will take the example of a girl who is finding a boy. Okay. Now let's get to a serious note now. You are finding a girl and the entire city is about 1 crore people. So suddenly this is divided into 2 parts, 50 lakh and 50 lakh, male and female. You are not going to find a male, so this male part is gone, forget about it. So among this 50 lakh, so the entire average age, it is, you know that 25% of the entire city is within the age of 25 and the rest of them is above 25. So less 25, above 25. Your age, 2025, you have just seen the girl and you have recognized that her age is around 19 or 20. So you are very happy. Okay. So age related problem will not be occurring. Okay. So let's, and after this, we'll do a very interesting thing. You will love it. Okay. And I will share that thing with you. So now within this less than 25 and more than 25, so you go for this less than 25. Among them, how many are studying? Okay, so you know the literacy rate is 50%, so among them only 12.5 is studying and 12.5 is not studying. Obviously, it's a medical student, she must be studying. And among them, how many are in medical student? Now the percentage is very low, it's like 1%. So now you're coming down to like 4,000, 5,000. And how many of the entire students of them are into your city? Maybe like that is another 1%. So it's actually you are finding from the 1% student, from this 1 crore people, you are finding from 200. That's it. And there are only maybe 2 medical colleges are there. So 200 girls are total students over there with respect to the girl population of your city in the present data. So your job is to find from 200 any 1%. Want to find in order to find your life partner? I think you should give it a try. So suddenly binomial is splitting the data and give you a hope in order to find that girl. Okay, now the interesting thing comes in. So do you think that in this way, will you be finding that girl or not? Now, in case of boys also, you can think in that way. So whether you will find the boy or not. Okay. Well, I will do a small figurative test at the end with respect to a binomial structure, and we will give you the result in front of you. I will not do it right now. So just remind me at the end. Okay. So binomial certainly make things is divided into 2 parts, again 2 parts, again 2 parts. So you are ending at a single point every time it happens, isn't it? So this is the magic of binomial. Okay, so it's not about expression, terms, and all. When I do the question, that's okay. So find the fourth term in the expression, find the seventh term from the left, eighth term from the right, find the term without x. These are okay. But the main thing is it possible to find it? For example, a number you have taken, a natural number. So again, divide into two parts, prime, non-prime. Okay. So every time binomial does this. So that's why we call it a binomial. We're divisioning into two parts which are not similar. So this similarity plays a very crucial role into the entire gameplay. Okay. Till now, any problem? So the consecutive term and middle term and all. Okay. Now, remember that I'm not going for the conventional type of question like find the nth term from the expression. So they will give you an expression. So what I'm not doing, I'm just showing you what I'm not doing. So this is an expression ax plus b by x. And they ask you to find the middle term of this expression. So first of all, how many terms will be there? Right? Anyone? Obviously 12 plus 1, 13. Why 13? Because if you forget everything, a plus b whole square has not two terms, it has three terms. A plus b itself has not one term, it has two terms. So whatever the power, one term is extra. So 13 terms. 13 terms is there, 6 here, 6 either, which make. So seventh term we are actually finding. Our job is to find out the seventh term. सातवां term निकाल लीजिए, काम खत्म. कैसे निकालेंगे? T7. So T7 निकालने के लिए आपको क्या करना है? T6 plus 1. Obviously, there's a formula to find it. So 13 plus 1 by 2, 14 by 2, and 7th. And if it is an even term, then the average of the 6th and 7th. So this is the 7th term. So the required term is T6 plus 1. So what is the 6th term? 12C6. A by x whole to the power 6, bx whole to the power 6. So again 12C6, a to the power 6, b to the power 6. This is 94, ab whole to the power 6. And as you can see, this term does not have any kind of a or x. So this is the term which is in the middle term, and it is independent of x. There's a very high chance that because one term has x equal to power 1 and another term x equal to power minus 1. In a normal case, we can only find it in the extreme cases. Okay, otherwise not. So if I just give it that ax square plus bx square and ask you to find the term which is independent of x, there is no term. Okay. So these are the type of questions which are very easy and the normalistic pattern. So, but one thing I will be giving you, okay, one shortcut for finding the greatest term. A shortcut method for, there's a long-term method you have already found out. So the greatest term in any expression. Okay. X plus a whole to the power n. So find the greatest term here. So x plus a whole to the power n, a to the power n, I can take 1 plus x by a whole to the power n. There is no problem now. Okay. Now let's calculate n. What is n? Mod of x by a divided by n plus a, n plus 1, then mod of x plus a plus 1. That's it. This you need to find out. Now, if n gives you an integer, then tm and tm plus 1 are the greatest terms and both are equal numerically. So you can find any one of them, there is no problem. But if this m plus a value is not an integer, let us say like this, then things become a little bit weird. GIF of m plus 1 we have to take. GIF of A means 2.79 of GIF gives you 2, so 2 plus 1, 3. Term cannot be in fraction. So the greatest term, so this denotes the greatest integer function. This is the GIF. This you need to find out. That's it. Isn't it easy now? So for any binomial expansion, if they ask you to find out the greatest term now onward, so you don't have to take that TR plus 1 by TR, then compare it, then you find it. This is the easiest way to do it within seconds. Okay. Next. But greatest term and greatest coefficient are not the same thing. Term is different. Term means the whole thing. Coefficient वो सारा family को लेके आता है. लेकिन coefficient क्या है? Family को लेके नहीं आता है. वो अकेला आता है. Okay. So if they ask you to find the greatest coefficient, then also it's okay. So if n is even, for example, greatest coefficient finding is a little bit easier also. So if the power is n and n is even, then the greatest coefficient is nc n by 2. If n is odd, then the greatest coefficients are nc n minus 1 by 2 and nc n plus 1 by 2. That's it. So these are the two greatest coefficients. You can take any one of them. Okay. So till now, any problem?
Sir?
Yeah.
So is it n minus 1 by 2 or n minus 1 whole divided by 2?
Where? This area?
For the odd case.
No, nc n minus 1, then whole divided by 2. And then nc n plus
Okay.
1, whole divided by 2. Okay. Now, there are some binomial has some very weird type of properties. Okay. So these are like theoretical zones which you need to do. Okay. Like one thing we have already done into our permutation combination days, like C0 plus C1 plus C2 dot 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 Cn. This is equal to 2 to the power n. Okay. So it is like 2 to the power n equal to actually like nc0, nc1 in that way, ncn. And if I just put it like nc1 or like c1, c3, c5, this is nothing but equal to c2, c4, c6, and that is equal to again 2 to the power n minus 1. Okay. Now, in my early days of teaching, I went to St. Xavier's College for teaching. Now, one thing happens at St. Xavier's College, there are many departments, physics, chemistry, mathematics. Not like ISI where almost number of departments are less. Undergraduate departments so almost hey. Most of the departments are postgraduate, only undergraduate department is B-Stat. That's it. In Kolkata there is B-Stat, in Bangalore there is B-Math. बाकी सब सीनियर है, मतलब जब घुसोगे तुम्हारे एज के और कोई मिलेंगे ही नहीं, सिर्फ 40 लोग मिलेंगे तुमको छोड़ के. ओके, तो सब लोग मिल के रैगिंग करते, सब डिपार्टमेंट के लोग. ओके, and as you guys will be the brightest brains into the institute, because masters का entrance उतना भी हाई फाई नहीं माना जाता है जितना undergraduate का entrance को माना जाता है. So obviously everyone has a little bit of anger and rush. So सब लोग मिलके बढ़िया से रैगिंग करते. So obviously, so St. Xavier's में जब पढ़ाने के लिए गया, you know, there are departments, or I used to take math classes. अब मैथ क्या है, फिजिक्स ऑनर्स के लोगों का भी है, केमिस्ट्री ऑनर्स के लोगों का भी है, जियोग्राफी ऑनर्स के लोगों का भी है, इकोनॉमिक्स ऑनर्स के लोगों का भी है, स्टैट ऑनर्स के लोगों का भी था, एंड बीकॉम का भी उन लोगों का डिपार्टमेंट था. ओके, सो कॉमर्स का वैसे तो मॉर्निंग में था, लेकिन व्हेन आई देयर वाज सम पर्टिकुलर सेगमेंट्स इन द आफ्टरनून So I never took the classes of the BCom, let's forget it. So as a result of that, whenever, so, and I was the most junior teacher over there. So what was my job, whenever there is a teacher is not there for these classes, so I was being sent. So as I am going, for example, so I'm going to this class, and then in the next class, then in this class, and also in this class, then also in this class. Okay. So every time I didn't used to remember what I did in the very last class. And whenever if I managed to remember it also, they said that this part is completed by the teacher. So I asked the student that which part is being done or which part I can do. So I ended up doing the entire 2 years when I stayed there, only revising someone else's classes, in these past sessions. They've given me my honor sessions as well. Okay. In these honor sessions also, I was revising some senior teachers thing. So I thought, okay, let's become a little bit senior, then come back to this teaching part. So, one thing I made it really very sure in those time, that in this kind of function, now I'm giving you this example, that all this subdivisioning, all this structuring is having a common connection, And that's, for example, all this honors has a common connection, that's maths. So here, permutation combination, number theory, binomial, multinomial, trinomial, whatever you say, that has a common connection, is that we try to make things a little bit quicker, isn't it? Through divisioning, sometimes through power and all, but our target is to always to make things a little bit lighter and faster. If we fail to do that, there's no point of doing it. Clear? Now, if we go to a little bit of higher extent, where our job is to expand the expansion, like we did in the de-arrangement pattern, when nothing goes in a proper chamber. Okay, so you remember that?
Sir,
Yeah.
so in 2 power n minus 1 formula, C0 will also be there. No?
In which one?
In 2 power n minus 1 formula,
Yes,
C0
yeah.
will also be there. No?
C0 will also be there. But I have not written, yeah. Oh, yeah, C0 plus C2. तब C0 जाएगा कहाँ, कहीं तो एक डालना है. Okay. One more interesting part. Yes, one of you asked me that is it the trinomial expansion is a expansion to the binomial? Yes, it is that. And sometimes we can do the calculation and directly put the value as well. This is also a possibility. But anyway, you don't have to pitch on that part. Okay. So you can directly do on normal things. Okay. Let's do on a small theorem. Okay. This is for one rational and one irrational part together. Root p plus q. Okay. Root p plus q whole to the power n if we have. And that is equal to I plus f. You can understand I means, any idea what is I?
Integer.
F.
Rest of the
Fractional part. Okay, integral part and fractional part. Obviously, I is a positive number, n is a positive integer, I and n is a positive integer, n being maybe here odd, n is odd, yeah, n is odd, and 0 is f is a fraction, as I already said, so 0 less than f less than 1. Then I plus f, remember this part, into f. So it's like if I f is nothing but equal to k to the power n. And what is k? K equal to p minus q square equal to k, that is positive. And root p minus q must be less than 1, then only the theorem will be applicable. Okay, this is a life-changing theorem for you for binomial. If you need a proof, I will do a proof for you. We have time. Okay, so this is theorem number 1, the most fundamental. The second one, if we do it, p plus root over q whole to the power n equal to I plus f, where all these things are seen. But here this theorem says I plus f into I minus f, the product of these things, is k to the power n, where p square minus q is equal to k greater than 0 and p minus root q is less than 1. So just an alternative. So you can see there is not much of a change in these two theorems. So you can prove one, then you can prove the other. So I will not be proving the entire part. I will just give you a hint so that you can give it a try. So this kind of problems you can face in the subjective. So root p minus q is less than 1. So obviously 0 less root p minus q whole to the power n is also less than 1. Let root p minus q whole to the power n equal to f dash, where 0 less f dash less 1. So still a fraction. So I plus f equal to root p plus q whole to the power n, 0 less than f less than 1, f dash equal to root p minus q whole to the power n, 0 less than f dash less than 1. Now subtracting, so if I just mark it, let me just mark, I haven't marked anything. So I plus f equal to root p plus q whole to the power n, that's 1. Where this thing is lies between these, this is 2, this is 3, this is 4. If I do it 3 minus 1, if I do it 3 minus 1, so I plus f minus f dash equal to root p plus q whole to the power n minus root p minus q whole to the power n. Okay. And remember that this is the old expression we did, a plus b whole to the power n, a minus b whole to the power n, irrespective of any value. So this is 2 n c1 root p whole to the power n minus 1 into q plus n c3 root p whole to the power n minus 3 into q3 plus dot dot. So this is nothing but 2 into an integer value. These all are integer. So that is an even integer. Clear? Since n is odd and RHS contains even powers of root p, so RHS is an even integer. So LHS is also an even integer, so that means I is an integer. Once it has been established, so f minus f dash value is also an integer. That means f minus f dash is 0. So that means f equal to f dash. Clear? Now, as we have already proved that this is an integer, so now I plus f into f, I plus f into f is I plus f into f dash. If I extend it a little bit here, the question, we are just about to finish it up. So I plus f equal to f dash, so these two are same, or from this on, what we can write? What we can write from here? Any idea? So that means root p plus q whole to the power n into root p minus q whole to the power n, which is equal to p minus q square whole to the power n, that is q to the power. Hence we can prove it. So if n is an even integer, then we can do it in the reverse way and come back to this value. So these are like two very crucial formation which you need to remember. Okay. In books you may find it, may not find it, I don't know. It's better you write it down, or you can take a screenshot of it. Take a screenshot. I don't think they will allow you to take the screenshot.
It is allowed, sir.
Okay, good.
So can you also show the proof so that we can take this screenshot of that as well?
Yeah. I generally don't do proofs, okay, but this proof you won't find in the book, so that's why I prefer to do that. So what kind of question you can face? In many of the cases, the theorem is marked the end of the class. The teacher comes and gives you the theorem, you mark it up and he goes on. But the question is, what kind of question can come? 5 plus 2 root 6 whole to the power n. This is odd. They have given. Or rather say, is the integral part of this expression odd or even? Tell us. Is the integral, obviously this will give you something plus something, something rational, something irrational, so something fraction. So is it this? So we can do it like 5 plus root 24 whole to the power n. We can do it like this. So root 24 is 4 into 6, 4 will comes out as 2 square, so 2. So let I plus f equal to 5 plus root 24 whole to the power n. There, where 0 less than equal to f less than 1. Now let f dash equal to 5 minus root 24 whole to the power n, where 0 less f dash less 1. Now adding these two is I plus f dash if. So 5 plus root 24 whole to the power n plus 5 minus root 24 whole to the power n. So this is I plus 1 equal to 2p according to the formula. For all values of p belongs to natural number. So this gives an even integer. So I equal to simply 2p minus 1, which is an odd integer. Hence, the given structure, which is I, is an odd structure.
Sir, how did you get f dash?
So I didn't get f dash. So here f is this, so f dash must be this. Okay, it's like A and 1 by A structure. So whenever you have this, f dash will be the opposite sign. So
Sir,
these
how is I plus 1 equals to 2p?
I plus 1 is not equal to 2, 2p. It's a
2p,
formula from the formula, direct from the formula I've taken.
okay.
So that was the formula, right? So even in these kind of formulas are so confusing that even if you do it by that, it seems like how is it coming? Yeah, it's a common thing. Okay. Next, divisibility kind of a thing, which we already did in normal way. We found our own way out. So that also can be done in these kind of topics like x minus x to the power n, a to the power n is divisible by x minus a. This we can show it by a binomial. X to the power n, a to the power n is always divisible by x plus a, when n equal to only odd natural numbers, plus minus 1 format. And this is for, the above one is for n equal to all natural numbers. For example, 2, 2, 2, 2, 5, 5, 5, 5, and 5, 5, 5, 5, 2, 2, 2, 2. This is a RMO favorite question, RMO, INMO, NRMO. So in these kind of questions, this like very famous. And you need to check whether prove it actually, it is divisible by 7. Okay. So here by this thing, it is becoming very easier. So I have solved it, and by binomial, how you can do it, this is your homework. You need to show that this is divisible by 7. Next.
सर इसको एक्सपेंशन करना है
So yeah, इसको show करना है, show that it is divisible, or show that remainder equal to 0. Okay. And last thing for today, the most interesting thing is last digit आप लोगों को पता है कोई भी एक्सप्रेशन का लास्ट 1 डिजिट, लास्ट 2 डिजिट दिया हुआ है, इंटरनेट पे ढूंढने से मिल जाएगा, पर इंटरनेट में जो नहीं मिलेगा वो है लास्ट 3 डिजिट, 4 डिजिट, 5 डिजिट, 6 डिजिट, 7 डिजिट, 8 डिजिट, 9 डिजिट, 10 डिजिट, 11 डिजिट, 12 digit. In that way, any digit you can find. Nowadays, internet is filled up with very cheap level educational videos made by class 7 fail, 8 fail, 9 fail people. Those who are just try to make some good cash out of it, and many people watch that as well. So that's the faith of an country like India. Okay. But anyway, don't try to learn it in that way, because anything really good, if you want to learn, so you have to go it by a tough thing. Okay, so the upcoming 10 minutes of the class is going to be really hard, and try to put full concentration in it. Okay, so let's get started. So I will be giving you a pattern, so which will be useful for anything. Remember that for normal 1 digit finding, it becomes very easy. I told you the way out. So if I tell you 3 to the power 400, find the last digit. So within seconds you can find it, right? What is the last digit here? 1, isn't it?
Yes, sir.
See, within seconds we can find it. But with my formula, it will take a long time. So you say, why should we do? I said, you don't do for 1 and 2. You do it for the other cases. For example, even 2 digit, 3 to the power 4. So 3 to the power 4 to the power 100, so like 81. So that to the power 100, and you do the rest of the stuff very easily. So the hundreds formula. So this and this to power, and this will be power multiplied with this. I told you this. So this is easy, right? But 1 digit and 2 digit, you need to learn it. But for 3 digit, it will be a little bit harder for you to do it in the very beginning. Okay. So let's do it for just, we start with the last two digit. Or let's find it with the last digit. Chale last digit se karte. 17 to the power 256. What is the last digit? So forget the formula. So this is 17 squares whole to the power 128. Why I'm doing 720? So why I'm doing 289? That is 128. That is 290 minus 1. So I need this 1. So that's why anyhow I need a 1. For every expression, we will find it anyhow. Maybe in the first, second, third, fourth, fifth, seventh, 10th step, kahin na kahin aapko 1 nikalna hai. Again, the binomial concept. 1 and the rest. Okay. So 7 to the power 256 now is a binomial expansion, which is 128C0 into 290 to the power 128 minus 128C1 into 290 whole to the power 127 into 1 to the power something, doesn't matter, plus 128C2 290 whole to the power 126 minus, in that way it goes on, and the last value is minus 128C 127 to the power 290 plus 1, isn't it? Now for the last digit, what we can do here, now see the magic. So you take 290 common, okay? So this thing will be 128C0 into 290 whole to the power 127, isn't it? Minus 128C1 into 290 whole to the power 126, in that way, and plus 1. This is this plus 1. Okay, remember this is this plus 1. Clear? Any doubt till now? So this is 290 into K plus 1. 290 into K plus 1. Now for last digit, now comes a little bit of twist in the formula. So for last digit finding, we will do it. Now I am going to introduce with the theory at how I get it. Now the theory comes in. Okay, so that's why I said you need to be very cautious. When the theory comes in, so it's in the middle of the question. So if it is a 10K plus minus 1 whole to the power m is the expression. And you have written is 10K to the power m plus mc1, 10K to the power m minus 1 plus minus 1, obviously, because we don't know whether the next term is plus or minus, depending on this plus minus, plus mc2, 10K whole to the power m minus 2, again a plus minus 1. And that way it keeps on going until it's a plus and plus minus 1 whole to the power m. It ends up like this. So for last digit, so for the very last digit, what you can do? What you can do for the very last digit? So this is 10 into lambda. You can take 10 and anything. So this is the lambda. So this is the 10 part and the 10 lambda part. And plus of plus minus 1 whole to the power m. That has been expressed. So that is the last digit. For last digit, we do this. For last two digit, we will be going in a way so that we can take 100 common. 100 mu plus m c m minus 1 10K plus minus 1 to the power m minus 1 plus minus 1 to the power m. For last three digit, you need to take it to the 1000 and you can do the expression. So now let's get back to our question. Is as 290 is there, so there's always a 0. So it's a 0 plus 1. This will end up with 1. So if we want to find the last two digit, So 17 to the power 256. Now we have to take it common in a way. We need to take that 290 square common. Okay. So now here, so for last two digits, let's take 290 square common. Last three digits will be taking 290 cube common. So if I take 290 square common, so something expression will come. Okay. So 128 C0 290 whole to the power 126 minus 128 C1 290 whole to the power 125 plus 128 C2 290 whole to the power 124 dot dot dot. In that way it goes. Okay, this is an expression and some extra terms. And you left out with minus 128 C127 290 plus 1. Okay. So this is now this expression is 290 squared. So it is already having two zeros. You're getting my point. Here it is 290 into something. So it is 290 into something is lastly digit 0 and 1. 0 plus 1 is 1 for sure. So here we have that 20 common. So the first expression is useless. So till this part, the expression becomes completely useless because it ends up with double zeros. The first two ends up with the double zero. So the only thing becomes relevant to us, double zero minus 128 C127 into 290 plus 1. So what is that minus 128 C127 into this and that? Okay, what is that value? Tell me. So that part is 100m. So we can write now here. So it is like, why I'm writing 100m intentionally? Because anyway, this doesn't play any role over here. Okay, so this is 128. We can take common 128, and this is like 290. So 300 minus 10 we can write, or you can just calculate this. Forget about it. You just calculate this. It will be easier for you to understand. Otherwise, I will keep on taking common. So whatever it is, whatever where it will lead, 128 C 127, it will lead at so like minus 128. So if you have forgotten everything, so 127 and 1 factorial into 290 plus 1, so 128, 127. So this is anyway gone. So 128 into 290. So minus 128 into 290 plus 1. So anyway, the lowest terms will end up with this. So this will be ending up with 0 and 8. So ultimately this is 0, 8 plus 1. And there is a 0, 0. So 0, 0, 8, 0, 0, 1, 1 and 8. So the function will end up with 8. Done. Now if you want to find the last three digit, you need to do it in a way so that you can take the last three digit common. So like it will be 290 to the power 3 will be taking common, right? And
sir, minus two?
Which minus? Yeah, this is the minus. Yeah, this is the minus.
No, minus 128 into 290. No.
Yeah, it doesn't matter. Yeah, here, for example, here if you have a minus also, so it is again having together. So minus 128 C0 and everything having a 0. Okay. So or else you can do it in this way. So 100m. Okay, minus this expression. So minus, that's why I was doing it in that way, because some of you will have a problem. So let's do it in this one. So 100m. So 128. So this is what? 300 minus 10 plus 1. So 100m minus 128. So this we can take into consideration into this part. So let's take it 100 common here. Okay, if you take 100 common, so m. So if you take 128 into 300, so this is 384. If you take 100 common, so 384 minus plus, so 1280 plus 1. So this whole thing is having a last two digit 00, and these two thing is 100 into m minus 384 1281. So ultimately this two ends up with the 00, this two ends up with the 81. So the final thing ends up with the 81. That's it. Okay, now as I was saying, the last three digit now. So in case of last 3 digit, you have taken 293 whole to the power 3 common, and your job is almost done. So now you are having with 128C0, and that is into 290 whole to the power 125. So how many terms? So you have to start with, you don't need to do anything afterwards. So 3 plus 5, so 128. Directly you can jump into this. And minus, so here 3 terms, and even you can start with this. So this is like 1000n, anyway that term is gone, plus 128C 126 290 square minus 128C 127 290 plus 128, so anyway 290 itself, the minus plus, so the last term is 1. Okay, clear? Let's just calculate this thing in your own way and you will find the last digit. So obviously you need to find this full calculation, otherwise it is not possible to do it. Okay, 128C 127. So this is only one big useless calculation you have to do. And let me just calculate in my phone and just tell you. Okay, this will be 683,527 000 plus 680 plus 1. So 681. So last 3 digits is 681. So obviously you can understand for last 4 digits you have to do an extended analysis. It's not a one-liner, it's possible with that. Okay, because even utilizing the best of the scientific calculators, you can't find the last 3 digits or 4 digits of this expression. So this is the magic of binomial we have done. In the next class, we'll do 2 result, 3 result based small equations, and we'll do some theorem based questions, and then test of mathematics, and then past year questions. So hopefully you have enjoyed the session, right? Yeah, good. So in the next class, we will be working on something more. And as usual, this class is being recorded from my side, so it will be uploaded on portal as well. Okay, so that's it for today.